Alright class, it is time for us to begin our second video. Hopefully you've got your notebook paper ready because we got to take some notes. Remember, you can pause the video at any point to, if I'm going too fast for you. But we're just going to jump right in because there really is no way to really explain this unless you just see it. But before we begin though, I want to give a shout out to Zachary Kalish. Thank you for the idea to use a different camera. I hope the quality of this video is better than the last. So, here we go. Today we're learning about the Pythagorean theorem. Some of you are probably looking at this word going like, what is that? Well, this is the Pythagorean theorem, okay? And it was come up by a long time ago. Some old Greek guy named Pythagoras came up with it. It has to do with triangles, and you're going to see what that looks like. But first, let's actually write it down so we have it in our notes. And here's what it is. You're going to write down a, lowercase a, squared plus lowercase b squared is equal to lowercase c squared. So that right there is the Pythagorean theorem. And if that's all we put down in our notes, that would not be enough. We'd be confused. We'd be like, okay, but how do I use that? Like, what is it used for? Well, here's what it's used for. Triangles. And not just any kind of triangle would work, but it has to be a right triangle. In case you're a little forgetful about what that looks like, remember, right triangles are triangles that have right angles. And some of you are going like, I still don't know what a right angle is. I don't remember that thing. Well, right angles are angles that have 90 degrees. If you don't remember what those are, you had better go back to elementary school and ask some questions. I'm kidding. You can talk to me at some point. But this is a right angle. You see, it basically makes that L. That's a right angle. Makes the L. And in math, they show right angles by putting this little box right in the corner that says, hey, this is a right angle. It's not 91, it's not 88 degrees, it is 90 degrees. So we have our right triangle. Now let's label the sides. You need to label it the same way I do because it is important. This is A, this is B, and this is C. Now the A and B, they don't really matter. You can kind of interchange them. They're the legs of this triangle, okay? So after you label them, it would be helpful for you to draw some little arrows like this, saying, hey, I got an arrow over here. Hey, I've got an arrow over here. And I'm just going to connect these arrows because these are the legs of this right triangle, okay? And like I said, they're kind of interchangeable. You can always tell what the legs of a right triangle are by finding the right angle. Find the right angle. The two sides that make the right angle are the legs. See? Right angle. This makes up the right angle, this side, and this side. So, those are the legs. This guy over here has a funny name. Almost sounds like hippopotamus. But it is called the hypotenuse. And that is spelled H-Y-P-O-T-E-N-U-S-E. Hypotenuse is how you say it, not hippopotamus. So the hypotenuse. Before we go on, one really big important thing you need to know about the hypotenuse is that the hypotenuse is always the biggest side. It is the biggest side, okay, on the triangle. So the hypotenuse is always going to be the biggest, okay? That should make it easy to find. Another way to find it really easy is just to go to the right angle, right here, find that little corner where the right angle is, and look straight across from it. It's not touching it. So look at this guy, go across, ding, here we go, hypotenuse. It's important that you be able to find it because if you don't know which one you're using later on, it's going to be difficult to apply this to something like this. Now let's get into the first example. Some of you might be still scratching your head wondering how does all this work, okay? Well, after we do the first examples, I'm hoping it clears it up. Example 1. Let's get to our first example. Let's say you're given a triangle that looks like this. And you see, triangles don't have to be written in the same way as ours up there. They can be rotated to different angles. So we're given this triangle, And we're told that the length of this side is 6 inches, while the length over here is 8 inches, okay? And we're told we don't know what this side length is. So they just label it with C. So they put a C right there and they go, okay, we want you to find and tell us what this side length is. And you're scratching your head going, I don't know how. Well, let me show you how you can do it. If you use this theorem, we plug it in. So we have our a squared plus b squared equals c squared, right? Plug in the values. This is a leg right here, so I'm going to use it for a squared plus, and this is the other leg right here. Remember, they make the right angle. And so I'm going to have 8 squared right there. I don't know what c is, so I'm going to have to put c in the place of c. Sometimes it can be any variable. They don't have to use c. They can use x, they can use y, they can use z, they could use q. You know, they're going to use different variables. Typically, though, they're going to use x or one of these up here, but they don't have to. All right, let's now solve it. This now becomes, guys, just an equation to solve. You guys should know what to do. We follow the order of operations and we try to get the variable by itself. So first things first, we got some simplifying that needs to go on. 6 squared? No, I can't add that to 8 squared. I've got to do exponents first. So square it. So we end up with 36 plus 64 is equal to c squared, because I can't square variables. He's just staying there for right now. Don't worry, we'll get rid of this squaring in just a minute. We add these two numbers together and we end up with 100 is equal to c squared. Are we done? No. I want to know what c is equal to, not what c squared is. So we've got to do one last step. We have to undo squaring. Anyone remember what undoes squaring? What cancels it out? What gets rid of it? Well, hopefully you do. We just took notes on it the other day. It is the square root. Remember, when solving an equation, whatever you do to one side, you have to do it to the other. So if I take the square root of this side, I have to do it over here. Let's do that. Square root of 100 is equal to the square root of c squared. I just told you that these two cancel each other out. So if you do both of them at the same time, it cancels out and I'm left with just c. So I have c on this side and the square root of 100? 10. It's 10. Voila. And that's your answer. Now remember, these were given to us in inches, so your answer would actually be C is equal to 10 inches. And here's something you guys should notice. I told you before, hypotenuse is the biggest side. When you get your answer, it should be a number that is bigger than the two legs. This leg is 6, this leg is 8, well this hypotenuse is 10. If you had gotten 7 as your answer, or 5 or 2, you have done something wrong. And that's a good way to check, guys. If you're looking for the hypotenuse, it should be the biggest side. Now, we're not always looking for the hypotenuse. Sometimes we're looking for a missing leg. So let's look at an example when we're looking at that. Okay, so let's say they give us a triangle like this one. And it also is a right triangle. And this side over here is 14 centimeters, and this side over here is 12 centimeters, okay? And this is unknown. We don't know what it is. We're going to label it with X. Let's get to solving then. Pythagorean theorem. I find it helpful if you just go ahead and write it down for each problem until you really get used to it, okay? Some of you might not want to do that. That's fine, but this is my recommendation. Take it for what it's worth. I'm going to write down a squared plus b squared equals c squared. Make sure you're putting the squares up high enough that you don't think you're multiplying by 2, but that you're squaring. There's a difference. You'll get it wrong if you get it mixed up. All right, let's keep going. Almost done, guys. Let's plug it in. I have 2 legs right here. One's x, one's 12. Let's plug them into our a's and b's. So I don't know what this guy is, so I'll put him right there. He's just x squared plus 12 squared is equal to 14 squared. The 14 comes from the hypotenuse, and that's what our c is. Remember it. All right, let's square them now. X squared, don't know what it is. 12 squared, that's 144. And 14 squared, anyone remember? 196. Yeehaw! All right, let's keep going. What do we need to do next? That's x squared. I left off the square. Make sure you put the square there. Well, it looks like an equation we've seen before. How do I get rid of, I want the x by itself, so what do? Subtract, subtract. Yeah, we need to subtract. So let's get rid of this 144. So what does this equal? Well, I'm left with x squared is equal to, well, what does this equal? Anyone want to take a gander, take a guess, make an estimation? Anybody? Anybody? Takers? Well, this would be roughly, what, 52? Is that right? If we subtract, it should be. Yep, yep. So we have 52. I want to know what x is, not what x squared is. Take the square root of both sides. Square root of x squared is equal to the square root of 52. Now, class, this section might tell you to round to the nearest, it might mention, hey, round to the nearest whole number. Then you would round to the nearest whole number. If it says round to the nearest tenth, then you're going to have to estimate the decimal, okay? And that's how, let me show you how we would do that on this. What you would do for this is you would say, well, what is this close to? Well, I'd have x is equal to, and remember, the perfect squares this is in between is 49 and 64. So it's somewhere between, I would say, somewhere between 7 and 8. Well, it's pretty close to 7, but it has to be a little bit more than 7 because 52 is a little bit more than 49. So I would make an estimate. If it said round to the nearest tenth, I would say, well, this is probably going to be 7.2. Okay? And since it's telling us to estimate to the nearest tenth, if you guys are a little bit off, that's fine. I'm not going to count off for that, okay? So just know that when it says round to the nearest tenth, you need to include a decimal, and you just need to think about that so that it's around like 7.2. Now, if we had had something like the square root of 60, and it said round the square root of 60 to the nearest tenth, well, that's about, I would say, because it's closer to the 8, it would be about 7 point, I don't know, maybe 7.8, 7.9 maybe. I think you guys will get the idea. So you see this one, because it's more, it's closer to the 8, but it's not as much as 8, because it's a little bit less, so a little bit less than 8. So I say 7.8. Well, over here I said 7.2. So that's how that works, guys. Let's recap real quick. Pythagorean theorem is a squared plus b squared equals c squared. The a and the b are the legs of a right triangle. The legs make the right angle. The longest side is the hypotenuse, and it is the c value. It is the c squared all by itself. Some triangles are missing the hypotenuse, and you have to find out what its value is. Sometimes a leg is missing, and you have to find out what its value is. And the last lesson we learned is, in this section, when it asks for a square root of a non-perfect square, it might tell us to give to the closest integer, which for this would have been 7. But if it says round to the nearest tenth, you need to estimate how close you think it would be. And as I said, if you put 7.1, even if you put 7.5, I would not count off. But your job is to get as close as you can to the actual answer, okay? So, that's the end of this lesson, guys. I hope you enjoy. Take good notes and watch it again or replay any parts that you need to go over. And we'll bring any questions you have to class. And be prepared to do a note check when you guys come in, okay? Or a note quiz. See you tomorrow.